Good afternoon, dear students. Today we have the sixth practical lessons about productions of vectors. The previous one was about geometry properties of vectors and so on. So we just did adding, subtraction vectors, and also multiplied by a number. And today we are going to study production. By the way, one organizational moment. If you noticed, our recordings were moved to YouTube just to save disk space. So everything is up to date. There are all lessons that were. But let me know if you have some problems with access. Okay, and for now, the first question is what you know about vector production. First, let's talk about scalar production. What is it? How to calculate? Okay, Adrian, go on.
It is we multiply two non-zero vectors, and also we multiply by cosinus phi. Phi is the angle between two vectors.
Actually, we have two ways of multiplying vectors, yeah, and how to do it. Yeah, so we multiply magnitudes of two vectors multiplied by cosine of the angle, and the other way to calculate. Other formula, Daniel.
We get coordinates of this vector, for example, x1 multiplied by x2, and add this multiplication. x1 multiplied by x2 plus y1 multiplied by y2, and the same with that.
Okay, correct. Well, let's start solving tasks, and we will talk about other production of vectors a little bit later. But yeah, we will talk about all of them. And the first task is to calculate this. So we have modules of magnitudes of two vectors, and we need to calculate magnitudes of such vectors. And we have to remember some properties of these vectors, of scalar composition, and how to solve it, by the way. So what do you remember about, so which properties of scalar, or the scalar production?
It is commutative.
Yeah, it's a correct property. What else? Maybe anybody else? So new people for today? Okay, Daniel. Which of them are we going to use here?
Sorry, can you repeat?
Which properties of scalar production are we going to use here in this task? to calculate such production?
I think it can be used if vectors are perpendicular, so the scalar product is 0. I think we can use this because
But we cannot be sure that these vectors are orthogonal.
I see.
Okay. Let me remember some of properties. So associate rule. So if only one of vectors is multiplied by a number, we just move this number out of brackets. And also distributional rule. It is written in the next way: A multiplied by B plus A multiplied by C. Yeah, and so if vectors are orthogonal, actually, yeah, that's correct. Useful property for us. If it means that their scalar production is 0, so it's a useful property. And by the way, what if I multiply so unit vectors one by each other? So y by y, or I by I, for example.
Maybe we'll get 1.
Yeah, on one, actually. Yeah, correct. Okay. Now let's start with solving this task. So let's start. Let's write it in details. So how should we solve? I will just copy and paste it. So using associative and distributive rule. Now what I have. So I move 3 out of brackets and I multiply, why it's not drawing, A1 by A1. So this part. So this and this. So then I need to multiply this by this. So 6A1 multiplied by A2. Like a regular production of numbers.
can you explain please it twice?
Okay, just a moment. I will finish and then we'll explain it for you better. Just a moment. So, just a regular, we will draw analogy. Imagine that we have usual numbers. And it will look like AC plus AD plus BC plus BD. And we do the same for these vectors. So I multiply 3a by a1. Here it is. Then I multiply 3a1 by 2 a2. Here it is. Then minus 2a2 by a1, this one, and this and this, and we have this part. So is it understandable? No. Any questions?
No.
Okay, and now let's calculate. I will delete my drawings for now. Let's continue. So for some reason it's not drawing correctly today. Okay, now let's use just a rule of module of A multiplied by module of B, and then multiplied by cosine between those angles. So the first one, so we multiply 3